Let's go.
All right, we're going to start with this problem from structural analysis, homework number 7. We have a frame with distributive loads and horizontal loads, and we want to find the shear moment diagrams and the redundant reactions. So we have our frame. We have a distributive load of 2.5 kips per feet and a horizontal load of 25 kips. And we first want to see the degree of indeterminacy. We have 5 external reactions, and from there we take that and we calculate our degrees of indeterminacy, which is 2 degrees of indeterminacy. That's step 1. Now, we take...
Use the black one.
Use the black. We take our frame and we make our real frame, and we take away the redundant reactions. In this case, the 2 redundant reactions that we're going to take away are the 2 bottom supports, which are located over here. We're taking these 2 out. And now we go on to our real frame right here. And we're only left with the fixed support, which is holding up the entire structure. We have our distributive load and we have our horizontal load. Okay? So now we find out our reactions at the fixed support. At the fixed support, we have 3 reactions. We have a moment, we have a shear, and we have a normal force. So to find the normal force, I take the 25 kips, and which in this case is acting in the negative direction. We need something to counteract that, so it's going to be acting in positive direction. So we have 25 kips, positive 25 kips. Now we convert the distributive load into a point load, and we're left with 65 kips acting down, so we need something to counteract that, and that's going to be positive 65 kips. Now, to find the moment at the fix, we calculate for a moment about this point at the fix, and we end up getting 445 kips per foot, acting in the negative direction. Now, we move on to our unit frame. Once again, we write our fixed support, but this time we will have an imaginary 1 kip load acting vertically at the bottom of the frame. So imagine having a roller support over here, and you have a 1 kip load acting up. So again, we do some statics work, and we have 1 kip acting up. At the fixed support, we're going to have 1 kip acting down because it's counteracting the 1 kip that is acting up. We have no horizontal load at all, so the horizontal is 0. And to find the moment about this point, we end up having a moment of 20 kips per foot. Change markers. Because everybody in the bank. Good, Carlos. A little bit more. Let me just write 20 kips per foot because we want to have as much detail as possible. Okay.
Don't worry about those units and stuff.
Now we do our second unit load frame. This time we have
Go.
a
Carlos,
horizontal.
stay on the left board.
Carlos, I think you gotta raise that.
Yes, we will stay on the left board. Stay on the left board, okay?
I'm sorry, the camera is like pretty.
So while we're right here, right here at the bottom, the second unit load frame.
You can raise that if you want.
Carlos, erase,
You can raise that.
yeah, that's what I was saying, like, keep it in order, so, yeah, there you go. Not this, just, yeah, it determines the.
Yeah, and the question as well, now you lost that. Because you don't have that space. Yeah, raise it.
Yes, so now we have our second unit load frame. This time we have our roller support giving a horizontal load
Label what truss is, what,
at point A.
which one here?
The bottom portion of the frame, by the way, is point A.
Carlos, label each frame, what it is.
So unit load frame, this is our real frame. This is our unit load frame 1. And this is our unit load frame 2. Okay. So in the first one we had that it was going vertical. Now in the second one we have a horizontal load of 1 kip, an imaginary 1 kip load. Okay. Now, of course, we need something to counteract it at the fixed support. So we have an imaginary 1 kip load acting positive. At the fixed support, we're going to have a negative 1 kip load. We have no vertical, so the vertical is 0. And we won't write that down. And we have a moment of negative 24 kips. Okay. Now, we go on to doing our moment equations. Because once we do our moment equations, we will be able to carry on our equations to find the reactions, the redundant reactions. So now we will do we'll do a cut on the real frame. Our first cut on the real frame. So we take our real frame, we rewrite it. We have, you know what, how about we erase the unit load frame 1 momentarily. For the sake of more room. Because for these subsequent steps, we need as much room as possible. So we have a cut from 0 to 8 feet. 0 to 8 feet right here. We want to find our moment 1. Our moment 1 is going to be 0 here. Why? Because there's no load, no horizontal load, no vertical, no nothing causing a moment over here. So our moment 1 is 0, from 0 to 8. Now, from 8 to 24, we do have a moment. Well, what's our moment 2? Our moment 2 is going to be these 25 kips times x of 2